Hello. You are making a game. Games often have a lot of content. That is stuff like enemies, items, character classes, resources, spells, dignity, dialogue trees, buildings, cards, outfits, Tetris pieces, etc. And while some content makes sense to lay out in like scenes for level building, a lot of it really doesn't. Maybe you want a piece of content to be stored and shared across the hierarchy or in multiple scenes. Maybe you don't want to slot it into the scene structure at all, or have it run and update every frame, or give it a transform with a position. Yes, it makes sense to have a scene with nodes that represent furniture on your spaceship, but do you need a node to store the concept of wizard at position 000? Ridiculous. Resources don't have that functionality. They're just data containers. Well, they can actually be a lot more than just data containers, which I'll cover later, but to start with, we can think of custom resources as lightweight ways of storing data in a semantically satisfying way. So let's think of content as data that is separate from the mechanics or the functional part of your game, as well as any transient state. Although a lot of content, and think of spells in an RPG or card effects in a trading card game, blur the line by having a lot of really specific functionality. Can custom resources support that? Hell yeah, and we'll cover that a little bit later. I'm going to talk about how you can build massive amounts of complex game content with resource types and why you should do it. I'm structuring this into a few parts, each of which will give you a powerful new tool for expressing your game content with resources. 1. How to make a basic custom resource. 2. Making a dialogue tree with a recursive composite resource pattern. 3. Making item resources with the content characteristic resource pattern. 4. Building up functional item effects with the abstract functional particle resource pattern. And 5. A high-level view of how we could slot all of these together to build out a whole RPG-ish game. 2 quick notes before we begin. We're going to use Godot's resource class here because Godot is cool and absolutely not a cult, but you can probably do something similar with scriptable objects in Unity and whatever Unreal has if you're using Unreal. 2. In Godot, most built-in classes that aren't nodes are actually resources and derive from the resource class. Resources differ from nodes in a few ways, but most importantly, they can be saved to disk independently rather than living within a scene tree. Scenes are actually resources that have a node structure inside of them. Materials, textures, themes, media are all built-in resource types. That's not really the focus here. Instead, I'm focusing on extending the resource class to make custom resources for game content. So if I say resource rather than custom resource, I meant custom resource, and I am sorry for failing you. I've made a fun little adventure diorama in Godot to put our stuff into practice, and we'll make resources for a simple dialogue system and an item equipment system. All of these use assets from Kenney and Lousberg, and I will drop some links somewhere. They've got great stuff that is free and for donation. Meet Blofeld J. Firefang, a dwarf wizard with big dreams in a world that is not all that it seems. Anyways, collision and gravity aren't really important for this. Let's make some resources. We can make a new custom resource by creating a new script and giving it a class name and making it extend resource like this. Save it, and then we can create new instances of it by going to our file system, right-click, create resource, and search up the resource class name we made. Let's make 1, let's make 2, easy. When you use the export annotation here, you can expose variables to the inspector. They must have explicit typing, and we can add many types that Godot supports, as long as Godot knows how to serialize it. We can edit any values from exported fields directly in the editor, and this is great because maybe you've got a little brother who you want to put to work making some content and you would rather he didn't get his snotty hands all over your code. Or maybe you've got a designer that you're working with and you want them to make some content and you don't want their snotty hands all over your code. Either way, we can add primitives like strings, ints, custom enums, and we can also add collections like arrays and dictionaries. Yes, dictionaries. This didn't work in Unity. I don't know if it does now. Anyways, so you can see how those all show up now in Inspector and can be edited. And you can also add resources from your file system, like textures, sound clips, and packed scenes. And behind the scenes, they save into these fairly human-readable TRES files. I think TRES or TextRes. Note that stuff that is not primitive gets imported at the top here and can get referenced throughout. And because this is human readable, it's also really version control friendly. In exported games, Godot serializes resources as binary RES files for better speed and compression. So this is pretty powerful. We can export a variable to handle pretty much anything except node variables, or anything that derives from node. Now think about this, it makes sense because resources don't exist in the node tree. They generally exist within your file system. They could be inside of a node, but they don't know they are for sure. So we don't know what node they might be pointing to. So you can hold a reference to a mesh, the resource, or a material, the resource, but not to a mesh instance 3D, the node that uses those resources. And you can save a scene with a mesh instance 3D and reference it as a packed scene inside of your resource to instantiate later if you want, but not the mesh instance 3D itself. If you want to know more about the specifics of resources before we start getting into some cool stuff, I would recommend reading the documentation. Anyways, so you can't reference nodes through export variables, but do you know what we can annotate export variables for? Other custom resources. Think about this for a moment. This is a big deal. Because we can contain resources in other resources, we can create very complex data. Why would we want to put a custom resource inside of another custom resource? Hey, I'm not judging, but there's a lot of reasons. Let's start with one simple example. We want to be able to represent dialogue and choices for a visual novel or RPG, and we don't want to write all of that text in code, and we don't want to maintain it in code. We want to create a tree, a dialogue tree, and let's think about how a dialogue tree might be structured. Think about tree, tree, tree. By tree, of course, I mean a tree built out of nodes and edges that go between the nodes. Don't get confused by the term node. We're not talking about Godot nodes. We're talking about nodes, which we're going to implement as resources here. And the edges will also be resources because we want to give them custom data also. The nodes will represent the main content of a dialog box, and the edges will be the choices and where those choices lead. So I'll create two resources here for dialog node and dialog edge. In node, we'll have the main text and an array that links up all the edges. In the future, we probably want to let these nodes trigger some sort of effects, such as quests or to add items to your inventory, etc., but we'll come back to that in a couple sections. For each edge, we'll have a string that shows up as the choice in the dialog box, plus the dialog node resource that tells us what node we go to next if we pick this edge. In a more complex project, we may want to include conditionals here to hide or lock these choices behind game progression, character abilities, etc., but we'll leave that one out for now. So let's bring this scene to life here by making a dialog tree for this rogue here so we can have a little chat. I've already hacked together some simple UI that is listening for requests with this, so we can just go to this NPC here from whom I've exported a field for a dialog node and start building out a conversation. We have the option with resources to do them locally, that is to store them within the scene that they live in or within the node that they're being created in, or we could do them in the file system and import them. That way, if you make a change somewhere, it will be reflected everywhere that resource is. This can be a bit confusing if you're not expecting it, but it does make sense. All right, so we've built out a little conversation here and we can test it. Note that the UI I wrote will automatically give us a dismiss option if there are no next edges, so we can always escape from a conversation after everything interesting has been said. I wish real life had that. I'm going to call the pattern we use for this the recursive composite resource pattern. Don't look that up because no one else calls it that, but it could be handy to think about. Okay, we now have a dialogue system that someone can edit without ever touching code. What's next? Let's think about another really useful application for resources. Think about relationships where an entity is one or more things. In Pokemon, for instance, this is as simple as Dave the Squirtle is a Squirtle. And Squirtle is a type of a Pokemon species. In a fantasy role-playing game with Dungeons & Dragons flavors, Blofeld J. Firefang is a wizard class and a dwarf species. How do we store Dave's Squirtleness or Blofeld's wizardness and dwarfness? Students in their very first Java class might leap to inheritance as the answer. Since Squirtle is a type of Pokemon and Dave is a Squirtle, maybe we should have a Squirtle be a class that inherits from a Pokemon class, and have Dave be an instantiation of Squirtle. There are some major problems with this, though. Are we going to have to write 150 to 1,000-ish new classes, one for each Pokemon species? How much code duplication is going to be happening between these, since most species share very similar functionality? Who's going to maintain those scripts? Not your little brother who can't code. What about Blofeld? Is he more of a dwarf or is he more of a wizard? Should we try to make him inherit from both? Most languages do not allow this, and maybe that's for a good reason, because it's a mess. We want a simpler solution for storing these ideas, one that we can actually maintain. And could we perhaps use resources to deal with this? Yeah. The idea is that for content, which is data that gets defined in the editor and by designers and isn't changing at runtime, we use resource. And for state, which is data that changes throughout play, we use plain data classes, which can refer to resources to express is-a relationships. So rather than making new classes for every kind of thing in the world, let's define a resource that has that static data specific to each type of that thing. For a Pokemon species, we'd want to add things like the moves they learn per level, their sprites or 3D models, their base stats, and we'd have a single monster instance class that represents the state data for the monster. Monster instance would have a field for species, which is the is-a relationship here, and it can access all of the information from the species to which it belongs. But it also holds all of its own dynamic data, current hit points, moves, experience, whatever. Now, a designer needs to only create one new resource for a new monster type, and do some click and drag to build a new monster species. Instead of hundreds of classes to maintain, there's only 2 which we can fill up with bugs. The concept of Squirtle is kept in the resource because the concept of Squirtle never changes at runtime. The instance Dave the Squirtle, which has information specific to Dave that changes at runtime, is a data class that has a link to the Squirtle resource representing an is-a relationship. Dave is a Squirtle. Now we also know that if we want to save state, we only need to save the state data, and it will have a link or a reference to the species resource class. This is a major theme of the series I'm making, where we are very slowly building a Pokemon battle system, and I'll link that up somewhere if you want practice. So let's turn our attention to the world of Blofeld J. Firefang. A character state data class would get 2 resource fields, one that takes in a class, wizard, and one that takes in a species, dwarf. And it can now refer to data from either. It might ask the class resource if it's allowed to use a spellbook, or its race resource for its base 3D model or its poison resistance. And 2 is not the limit. You could compose much more complex content types with this. For the purpose of this video, I'm going to call this the content characteristic resource pattern. So an item resource in the game might represent a type of item, with any number of instances of that type living in the world. Longsword might be a item resource, and there can be hundreds of longswords. The item resource is going to start with fields for its name and its 3D model so that we can generate the items in our world and refer to them in our inventory. And later on, we're going to add some custom effects so we can spec out how they get used when you click on them. So let's spec this out. So I've already made a simple data class that will hold an item. I'm going to make a resource class for it now here. So it will be called item resource. And just like our dialog nodes, we have to give it a class name, item resource, and we'll make it extend resource. In here, we're going to give it two variables. We'll give it a name, which is going to be called name. It will be a string, and we have to make sure we @export it. And we'll also give it a model, which is just going to be a link to a packed scene that will have a mesh renderer for this, so we can have it show up in the world. Great, now in our content folder, we can create a resource. Look up item resource, and I'll call it staff. This will be the staff that Blofeld can equip. We'll call it staff of wizardry, and we can find a model for it in our imports here. And you can put whatever you want in here, but I'm just going to find a staff from this K-Kits pack here. That looks just fine to me. Cool. And I'm going to make a couple more items here. We'll make a spell book, which will also be an equipable. And we'll make a first potion. This potion is going to be something we use as a consumable, and it will be like a potion of healing, I think. You know, your typical everyday potion of healing. And I'll see if I can find a bottle of some sort to use. That'll do. And the last one is going to be another potion. I'll make a potion of mind expansion. And notice these are just item resources. We don't have to do any subclassing on this or anything. We're just giving them names and models, and then later we can add some more functionality. Okay, fantastic. So we've got our resources set up here. How do we make them live in the world? Well, I have made a script here called item renderer, which I'm not going to cover the details of at this point, but really all it does is look at the resource it's passed, and then it can render things based on that. But we'll make a node 3D for it, and it's got kind of a little bit of an interaction radius which we can use to interact with it, like for pickups. And it's got the little exclamation point thingy to just show that we're targeting it. These aren't really that important for this. Anyways, if we go here, these have an item resource. Again, all the inventory code and character code, they are sort of out of scope of this, but they are just essentially checking what resource is being passed to it. And this way we can have variable things being passed in. I'm going to make 3 more renderers here just so we can have one of each of our items. And you would want to edit this to work with whatever you're doing. Great, so I can pick up those. Great, I'll just pick everything up. Great, so those should all be in our character's inventory now, which is great. Now when we click on something in our character's inventory, it does nothing, but that's the next thing we can work on. I think we want clicking on these to equip the staff or the book or to drink the potions, but they're doing nothing. So how can we build out expressive, unique functionality for each of these items? There's no way we can build out this functionality within a resource, right? Wrong. So you can build out expressive functionality in a resource. And the solution is, you're not going to believe this, more resources. We're going to create a resource type that can implement a generic effect that can be triggered from items, dialogues, abilities, and any other system in our game. While I was writing this, Godot 4.5 came out, and with it, we got abstract and GD script. Now, abstract classes aren't a complicated idea. We can mark a class as abstract, and then it cannot be instantiated itself. However, we can extend that class, and in the abstract class, any functions that we mark as abstract will need to be overridden in the inheriting class. And now we can set fields to require an object type to our abstract class, but they can accept any objects of our inherited classes and call our abstract function that has a special implementation in each child class. Before 4.5, I just made a pointless class called useEffect that was not abstract, could technically instantiate it, but this is a lot cleaner and I like it. So I'm calling this useEffect, and we will have a method called do. Now the signature for this is going to really depend on your needs and how you want to architect your game. These can be very generic or much more specific, and you might need different kinds of useEffects if you want to be more specific. In this example, we want to kind of reuse stuff for both items and dialogue, and so I'm going to use generic objects and duck typing here, though you may want to clamp down on this for better data safety later. It's not really the best way to do this in the long term, but it does work. So the two args I'm going to use for all of my useEffects are user and source. User is going to be like the person using it, usually the character, and source can be something like the item or the dialogue node that's being used. And when we extend the script, we can queue up effects that will pretty much do anything. Let's make a bunch. For something simple, what if we want to trigger giving an item to your user based on reaching a dialogue node? So let's make a new script that extends useEffect. Since useEffect is a resource, the script will be a resource too, and we'll call it useEffect add item to inventory. We'll give it one export variable for the item resource, and we'll override do. Since I'm using generic objects, I'm going to duck type this as I said. We want to check for the method add item, and if they have it, I'll instantiate a new item with that resource and add it. In a bigger game, I would probably move this responsibility to an item controller of some sort, but this is fine for now. And the add item code is whatever code is run on that character that is supposed to receive the item. It's that simple. I'm not going to go into that again, but again, you can figure out how to just add something to an inventory. And we're going to make another useEffect here too. We'll call it useEffect pop interaction, and it will trigger some text to pop over a character's head. Again, since most of the actual stuff is happening in the other classes, these are really all about just passing that signal. We can pretty much copy the pattern from the add item effect, but change a few things, give it an exported text field, for instance, and call a different function from do, but it still has the same interface, so it can be used within an array of useEffects. Now let's add this to our dialogue node. We're going to update dialogue node to have an array of useEffects, and now we can add our effect resources to our dialogue resource. Keep in mind, my dialogue runner in the background now has a method that will look through each useEffect and run it. Just run its do function. But I'm not going to get into that because this is just about storing that data. And as an improvement, you may want to also introduce a can do method for useEffects just to check if an action is legal first, but I'm not going to in this case. Now our effects should be executed in order whenever we hit this dialogue node. We can try that, and we've got the item in our inventory. And it pops up some text. Awesome. This method of having an abstract resource type that can implement an overridable function that can be slotted in certain places and run, I'm going to call the abstract functional particle resource pattern. Again, this is my own personal name for it. I'm not sure if there's a real name. Up until this point, almost everything here could have been done just by serializing and deserializing JSON, XML, or some other text resource. With this pattern, we start using the real power of Godot resources. But we still can't use this item that's in our inventory. How are we going to go about doing that? Well, we've got two types of items, really. We've got stuff we want to equip, and we've got stuff we want to consume. So let's handle equipment first. The answer to this is to make another useEffect. Right now I have their inventory buttons. They send a signal to call a use item thing, which will, when we have effects on it, run all of the useEffects on an item. So let's create a useEffect to put on an item that will just equip that item. I'm going to add one variable to this called equip type. This is sort of specific to my implementation, but basically the models that I'm using have essentially connection points for things like 2H staff or spellbook. So I'm going to use that text to tell the model where to put the item on our character. Depending on your 3D models or assets you're using, there might be differences in your implementation, but we can put this right on our use effect equip use effect, and that should work great. And basically all we're doing here is we're going to override do and do a little duck typing and check if the user can equip something, and then we'll call it with the thing to equip. And it's just that simple. Now if we drop that onto our equipment items, and if we pick something up, and if we go to our inventory, we will see there's a staff, which we can put in our hand, and a spellbook, which we can put in our hand. And all we're doing is just adding a little resource here to pass on the message that if you click on this, you should run the equip method. And you could add another array, maybe of use effects for a weapon, like on hit effects, that kind of thing. Think about it. You could really do anything. Let's handle consuming items now. We want to create a new effect that just consumes an item when it's used. And since we can do multiple things, we can add multiple use effects to a single item that will be triggered on use, we can add consume as well as a useful effect. So use effect consume, I'm not going to type it all out, but all we're going to do is check if the source object has a consume method, and if it does, we run it, and that consume method can be responsible for destroying the item and removing it from a owner's inventory. Simple. And what about a more useful effect? Well, I'm adding a effect called expand mind that we can put on our potion of mind expansion. That's just going to shoot an event, so that's another option you can do here. Really, you can put any code you want in these do effects, so you can really go wild. Let's add these effects to here. I've added a use effect pop here. I've also made up one called use effect heal. That's just going to send a print statement because healing isn't implemented. We don't have any RPG systems. But again, you understand how, if you were making this, you could add some sort of call to heal the user here. Anyways, so mind expansion has consume and this pop text effect, and then it has this use effect expand mind. So let's see how these potions work. Now if we pick up our staff, we can pick up our staff, pick up our book, pick up each potion, talk to the skull, he'll tell you to like and subscribe, and you can say you're a rude boy because you've forgotten to. Anyways, click on your inventory, and you can take your potion of healing. It'll pop some text. We have printed a statement saying it's not implemented, and we can expand our mind. And that just messes with our camera a bunch. Very fun. That was mind expanding, and I hope this whole video has also been mind expanding. And we can reuse this kind of logic and even these specific use effects for all sorts of stuff, like spells, like abilities, triggered effects, conditions, etc. So we've got some dialogue trees and simple items working, but how do you build out a whole world's worth of content? I've introduced two core ideas here. The idea of representing a type of things, like item prototypes, classes, species, monster types, using a resource that you can point to with a data class or a node, and also having an abstract resource type that can be essentially used as a component, which can take in some sort of generic command and then output anything you want from it, like the use effects we put on our items. So between these two patterns, I think you could build out a lot of complexity in a system, notably in a way that is pretty easy to manage compared to working in code. We are not coding a full RPG system in this video, but I want to spend some time speccing out an imaginary system so you can understand how custom resources using the patterns we discussed, custom resources characteristic, custom resources functional particle, can scale up to build a whole game's worth of content. We'll keep with the fantasy RPG flavor here, but we're not limited to fantasy or even RPGs. It's just easy to think about, and we can lean on well-known tropes from D&D or JRPGs or whatever. At the top level, we have some overarching data state class that holds all of our top level state. This probably doesn't need any specific resources attached to it, but contains a list of state data like characters or items that are in the world. A character might have a resource variable for a class, like we said before, and a species. Class might contain some simple data about what types of items you can use or how your stats might grow. These could be represented with primitive data, enums, or even resource links. The biggest thing a class does if we're using D&D inspired worlds is unlock abilities based on level. Either you just get them, or you have to make a choice. If you just get abilities, they can simply live on the class, and we can use the character level to determine if you have access to them. If there's a choice or some other way to get abilities, then class doesn't fully define abilities, and maybe we have to put references to these new abilities onto the character directly when they are chosen. This is for you to decide based on your game's design. But abilities themselves should probably be their own data class, so they can store local data like cooldowns or power levels, and a referenced resource, which we can build out from. Let's look at an ability custom resource. Ability resources probably get a name and description, maybe an icon, but importantly, they should probably also get effects. We can break down abilities and effects into a few different categories. Passive abilities are the type of ability that have effects that are always applied. We can define those with some sort of resource that can define stat changes, plus 20 strength, minus 5 moxie. These could even be treated as conditions, which we'll talk about in a little bit. An active ability is the type of ability that can be selected, activated, and possibly targeted. Depending on your game's needs, these could use the same use effect resources as the ones we made for items and dialogue. An ability might also have triggered effects. For example, when you're hit, do 100 damage to your attacker, that kind of thing. These probably need a special intermediary triggered effect resource that define the trigger, handling targets, and storing randomness values, 50% chance to happen, etc. But that triggered effect resource could include its own array of use effects, similar to the ones for other abilities or items. All of these ability effects can probably be treated with some version of the functional particle resource pattern that I described earlier in this video when we built out functionality for items and dialogue nodes. Also, abilities can generally be generalized to cover any sort of thing a character can do. For example, attacks, spell casting, special abilities. If you want to split these up arbitrarily like Final Fantasy does with their menus, you can use the UI for that. Zooming back out a character's species, well, it can do a bunch of things. In D&D, it usually just gives a bunch of abilities, mostly passive, and drives stats. It's also probably where we want to define the visual representation of our character. I don't have it here, but fantasy characters might also have a background. Again, design resource, make resource, reference resource, profit. Let's go back to character. We've got a class, a species, maybe an abilities array. There's a lot of other stuff a character might have attached to it, skill values, mental models, relationships. But I think there are two other important content types that a lot of RPGs implement. An inventory for items and any current conditions. We already talked a bit about items in this video earlier, but let's quickly refresh what that can be. We want to have some sort of item state data type that references some sort of resource. Now, items could be composed like characters from multiple characteristic resources, or we could have a simple resource that stores all data for a specific item type. That's up to you and your needs and the amount of complexity you want to support. The important thing is that items probably need to have a function. Earlier in the video, we set up items to implement a list of use effect resources that would be triggered when they are used from the inventory. You may also want to define special lists of use effects for things like on attack or on hit by enemy. Again, we could use similar resources to type that out too. Conditions probably work similarly. I think conditions are going to be a state data type also, which will hold the duration and any special parameters, but conditions will also reference a condition resource. I spoke briefly about passive abilities and triggered abilities when I was talking about character abilities. Conditions probably have to implement those too. For instance, when you're poisoned, maybe your strength goes down and you take some amount of damage every 15 seconds. Conditions also probably need to define their rules for being removed. Is it duration-based? Can you cure with a potion? Whatever. Since conditions are persistent effects and we can use them on characters or even monsters, we could use them to store permanent or long-term effects for things like passive abilities or equipment that you're wearing. That's up to you if you want to do it that way. Again, if you do this, you want to use your UI to display them judiciously. Perhaps you only want to show the imminent temporary conditions on the HUD and hide the other 100 passive conditions in a stats menu. Alright, so that's my basic idea for a fantasy RPG character. You're going to probably want to add more things, but this could definitely give you a lot of functionality. But I didn't just promise you a character, I promised you the world. Let's fill our world with something else. For things like monsters and NPCs, we've got a choice. We could implement them exactly like characters, including having conditions and abilities and an inventory. And this works really well because then we would have to maintain less separate classes, but maybe monsters don't have to be that complicated, and maybe you want to just have a single resource that you use for them. Again, it depends on your game design and how much emergent gameplay you might want out of it. However, for these NPCs and monsters, you may want to add resources for things like an AI strategy or parameters for how aggressive an AI is, and also, as we saw earlier in the video, a node for dialogue. Great, we've got a bunch of characters and monsters floating in space, swinging swords and babbling. They need a world to live in. So a level or environment seems like the kind of thing you would actually not use a resource for, and maybe store in a scene. That's an option, but for games that have a lot of procedural generation, a resource is probably a better place to store parameterized values that you will feed into the procgen algorithms. You could also have a level scene that has a resource attached to it that holds values for things that are non-local, like weather patterns or random encounters. However, within a level, resources also play a huge role. You could use them to define and script out events, summon NPCs or progress quests, and you could use item data to place drops in the world, etc. So these games are complex, and this is just a taste of how I would structure out resources for a very generic world. Your needs will vary, but I hope these tools will help you think about how you can start structuring out your world with resources. So get started, scope out your game, or check out my series where we're building a Pokemon battle system with very similar patterns if you would like to understand this at more of a code level. There are so many other things you can do with resources. This is not the end. I've left a lot of stuff out for the sake of time and also because I just don't know about them. Here's a few things that I think I want to point to. You can override other built-in Godot resources to improve their functionality for your workflow and needs. You can build a resource library class that's used to store and serve resources as you need them at game time. You can create tools for designers to change their workflow with your own resources. Remember the dialogue system? It's not very fun to work in. That's not a great workflow for a designer. You could build a different one within Godot. Godot is extremely hackable. You could also use resources to expose modding functionality. I'm not too sure how this works, so I might follow up later when I understand more, and I do not know if it's a good idea. Similarly, you could use resources to save games and store other data like high scores, but I actually think this is a pretty bad idea. You can save resources at runtime, but there's something kind of semantically weird about storing save data as a resource rather than as simple JSON data, because a save game probably doesn't have any functional parts. Also, some people have pointed out that resources could be used to inject malicious code, which could be a problem if someone is downloading a mod or a save game from the internet and running it in a Godot program. Again, these are problems that we always expose ourselves to when we are downloading stuff from the internet, but it's just something to be aware of. Anyways, that's enough for today. Please tell me how you are using resources to build your world, and subscribe, like me, and I'll see you soon. Goodbye.